Hi, this is Stan. Welcome back to the Crow's Nest Railroad. Well, this week, a really cool opportunity. We're going to take a look at the process of putting surface mount technology on small railroading circuit boards. So don't miss this one. Well, I don't know about you, but I consider myself successful if I can simply solder some wires onto a small circuit board or maybe a large resistor or two, and that's about it. But we have the opportunity to go out to Dakota Clemens' shop, DC Custom Electronics, and he's going to show us what it takes to use actual surface mount technology components on the custom circuit boards that he builds for his railroading projects. This is a rare opportunity to see the actual process involved, and he has a company right here in the Phoenix area, so let's head out. All right, so here we are in Dakota Central. This is where all the magic happens, all the design and a lot of circuit assembly, and that's Dakota Clemens. And oh, this has so many toys in here, Dakota. You could just stay in here forever. So
yeah, it gets a little messy at times, but
listen, if for such a young guy, you've done so many amazing things in the railroad hobby and probably beyond that I'm not aware of, but give us a quick glimpse of your website, and I will put a link to the website.
it's dccustomelectronics.com.
Okay.
I do have a shop page with available products. Everything is made to order though, so for the most part things have to be assembled after the order comes in, and we'll show you that later.
Okay.
We do have wireless control systems and things to go along with that. I do locomotives as well, lighting, sound systems and signals, as well as other custom projects.
So this is where you do the design for your circuit boards as well as the assembly on these electronic parts?
Yeah, so I use a program called KeyCAD, and I can show you that program here. I'm actually going to open up the file for the board that we're working on right now. Give me a second to pull it up.
And we're going to see the assembly of one of these boards in action here.
So we have a schematic here. This is where I would design all of the circuitry on the schematic level. That's always where we start, to make sure that we have all of our components there and all of the circuitry correct before we go into designing the actual PCB board. After that, we go ahead and we move over to our PCB board, and this is where we start placing components, putting them where I would like them physically on the circuit board, as well as designing the size and shape of the circuit board. In this case, you can see we have some cutouts here for some mounting holes for screws. We have various components on here, and we'll see those later when we assemble it.
Well, what about the circuit tracing on the board? Now, do you have to design all of that as well?
So generally I do every circuit by hand. There are automatic programs that will route all of your circuitry based off of your schematic, which is why it's very important to make sure that our schematic is correct. The cool thing about this program is that once I've linked the circuit board to the schematic, all I have to do is click on a trace, and you can actually see that it's highlighted the trace that it goes to. And if I zoom out, you can see that it has highlighted the other pin that connects to the pin I selected. So it's very easy to run a new trace. As you can see, it's trying to let me do a new trace right now. And it will not let you run into other objects. So it's pretty easy to run those. I have some of my own kind of rules that I follow when I design the circuit boards, just to make sure that there's no issues in the production process.
Wow. And then the actual fab of the board itself, how is that done?
I use a program called JLC PCB, and all I have to do is upload my Gerber files, which I do have right here. It will automatically generate a preview for me, as well as extract the dimensions of the board. There it is. And then it gives me a price. I can select a quantity. I can also select what color I would like the circuit board to be. If I want it to be a red one, a purple one, a blue one. I do sometimes change the colors just to keep track of versions, different versions of the boards, so that I don't mistake them for an older version or a newer version. And then I can also come down here and create a stencil for the solder process, which we'll show you later how that works. Alrighty.
All right.
Well, should we get to it?
Let's get to it.
Alright.
All right, this is going to be a real treat because we're going to see Dakota's magic in action here. He's actually going to put together one of these little circuit boards with surface mount technology. This is something that would scare most of us to death. My fingers are not as friendly on the soldering iron as they were when I was younger, and so a lot of you have done fairly large components, but here we get to see what happens on a really tiny scale. So Dakota, this red board, what function is this little circuit board?
So this board here is actually a controller that interfaces with my wireless control system. It is for our air brake system.
Okay.
It uses a dual proportional valve, which is a electronic controlled dual proportional regulator, and it controls the air output from your locomotive to apply or release your brakes. So this board actually goes along with that valve to interface between the control system and the valve itself. So this is kind of a rudimentary way to do it. I haven't gotten around to getting actual jigs for doing solder stenciling. What I have here is I've just kind of taped some additional circuit boards to the table to create a right angle for me to position the board in. And underneath my stainless steel stencil here, I've positioned one of these boards, and I've positioned the stencil to match the componentry on the board. The stencil is a very thin laser cut precision stencil for solder mask. It matches all of the components and all of the solder points on the board. What I'll be doing is taking some of my solder paste and my little squeegee here, and I'll be working that solder down into each of the little grooves and onto the board. Once I'm done with that, I'll carefully peel the stencil off of the board and reveal the solder left on the board where the stencil allowed it to be.
Now, is it going to be heated so that solder is adhering to the board?
We will after we place all of the componentry.
Oh, okay. So it's like pre-soldered then.
Yeah, it's kind of like putting glue down and then putting your parts onto the glue, and then the heat activates the glue. In this case, we're using solder, so it'll actually make an electrical connection as well. It's actually microscopic beads of solder mixed with a flux. And as I work it, it'll kind of create friction and heat itself up, and it'll work a little bit softer as I go. I do have to be careful I don't put too much down into the hole, because I can actually squeeze it below the solder mask or the stencil, and that can cause problems for me later on. I'll actually inspect this with my microscope before we go any further after getting this on there. I'm going to carefully peel up my stencil now. It looks like we might have done a pretty good job this time. I'm going to go ahead and carefully pick this guy up and move it over to my microscope.
Wow.
It's actually even hard to see under the microscope. You can see the lines of solder paste on the pads for the main IC chip. And mainly I'm just concerned about that chip, because all of my other components compared to the chip, as you can see here, resistors, they're very big spaces between them, whereas the chip actually has very small spaces. So these components, the solder will kind of wick to either side, and it'll actually separate on its own, whereas the IC chip here, the pins are so close together, this extra solder here may actually make a joint that we'll have to come back later and separate.
Dakota, this is a sample printout that you have of kind of
Yes.
like a cheat sheet of where the components are located.
Yes, so typically that would match up with my board here. And this tells me my resistors and capacitors, my small components that are easy to confuse the placement of them. So I've gone ahead and just written out the numbers of each component so that I know what value to put in what place.
Okay, Dakota's giving us a view of the microscope's view of, this is an LED, a little diode.
Yes, this is an LED. It's the same size as the resistors we saw earlier. This is the tip of my tweezers next to it. And the little green marks you see on this side represent the negative end of the LED. So this one is polarized. It does have to go on the board a certain way. So I do have to be able to see which way is positive and which way is negative.
And that's what we were just looking at under the microscope. Unbelievable.
There's actually 3 of them here. These are green LEDs. And I can actually see the color coding on them, so I'm going to flip that one around and get it put where it belongs. Just going to pull 2 of these little Zener diodes out. Actually, I do believe there's 3 of them on this board. These components are also polarized, so it is very important to get these correct. I cannot see these with my naked eye, so I do have to use my microscope. So what we see here, this is actually a Zener diode, this little square box here, and it needs to go onto these pads, as well as another one on these pads here. This little black stripe on this side indicates the direction, and I actually do need to flip that 180 degrees. So my tweezers here are going to flip this around. And then I'm going to go ahead and grab it and very carefully place it onto my pads. You can actually see it likes to stick to my tweezers more than the paste, so I may have to get another pair of tweezers to get it off. Now we're going to start our hot plate up. We are heating this up to 200 degrees Celsius. And I'm actually going to place the board in the center of the hot plate while it warms up so that everything can heat up evenly. At this point, we just have to wait for the solder to melt and everything to wick into place.
(190 Celsius). It's looking like solder now. It's starting to get that little volcano thing.
Yeah, a
going.
little shiny surface to it. And all of the components do have a rating for how long they can be under heat. I don't approach them. Most of the time when you put them in a hot oven for this process, it would be about 30 minutes in the hot oven. And I do all the soldering in 5 to 10 minutes.
195. 198.
Yeah, it looks like everything's melted. Now that everything has soldered, we're going to go ahead and remove this from the heat, give it a little bit of time to cool, and then we will inspect it under the microscope. What I'm looking for here is any solder bridges or unsoldered pins. You can see very clearly that everything along this side looks to be soldered very well. There's no joins between pins, so I'd say we did a pretty good job. Okay, so what we're going to do is we're going to first flash the chip with our firmware image. We have a special connection on here that we have to connect when applying power the first time. We use a program called STM32Cube Programmer. Now that our program is connected, it's ready for loading the bootloader. We're going to locate our file, and then we're going to download our file to the chip. So now that our program has fully uploaded, we can go ahead and disconnect our chip and close out of this program. I'm going to bring over the next program that has to be loaded. This is from a company called Splat Controls. We're just going to go ahead and reboot our board. Now that the board is rebooted, I can go ahead and connect to it via our new program. I can test a few of my outputs, such as my status LED. And then we'll go ahead and load this program onto our board. That's all there is to it.
Wow, Dakota, that was awesome. Thank you so much. I really enjoyed that this week, and I hope you did too. Please check out Dakota Clemens' website, DC Custom Electronics, and look at all of the stuff that he creates for our ride-on railroad hobby. Well, that's going to do it for this week. I'll see you right here next time on the Crow's Nest Railroad.